Hello friends, we are going to start this question. If mod z less than 1, show that this left hand side is equal to this right hand side. How can I write this left hand side to be equal to? So for mod z less than 1, making the partial fractions for that we need to use the format a divided by z plus 2. I'm taking this first, plus it is bz plus c divided by 1 plus z square. So that is, we are getting 1 equal to a into 1 plus z square plus z plus 2 into bz plus c. To eliminate these two constants, I can put z equal to negative 2. If I put z equal to negative 2, this complete second term vanishes, right? So let's take z equal to negative 2. We get 1 equal to a into 1 plus minus 2 square, that is 4. So we are having the value for a to be, it is 1 divided by 5. And now solving for b and c to get the values of b and c. Let me mark this equation as star. Let's multiply a inside this and also z plus 2 inside this bracket. So we are getting 1 equal to a into z square plus a plus b into z square plus 2bz plus cz plus 2c. Let's collect the coefficient of z square, that is a plus b, and also the coefficient of z is, it is twice b plus c, and rest we have a plus twice c. Fine. When equating the coefficient of z square, here we can write this as 0 into z square plus 0 into z plus the constant 1. So when equating the coefficients of z square, we have 0 equal to a plus b. This is your first equation. When equating the coefficient of z, we have 0 equal to twice of b plus c. This is your second equation. And when equating the constants, we have 1 equal to a plus 2c, right? Okay. And because that from here we get a equal to 1 by 5, so from here we can get the value of b to be negative a, that is negative 1 divided by 5. So we have the value of b to be minus 1 by 5. And from here we can get the value of c. So c is equal to negative twice of b, that is c is minus 2 into minus 1 divided by 5, that is 2 divided by 5. This is the value for c. Let's put all these values of a, b and c back to the equations, the given equation, this one. Let's put all these values over here. So we have 1 divided by 1 plus z square into z plus 2 to be equal to, we have a divided by z plus 2, a is 1 by 5. So 1 by 5 divided by z plus 2 plus b into z, b is minus 1 by 5. So it is minus 1 by 5 into z, bz plus c, c is equal to 2 by 5. So plus 2 divided by 5, and in the denominator we have 1 plus z square. In the numerator, if I take minus 1 divided by 5 common, I will be getting z minus 2. So writing the numerator as negative of z minus 2 divided by 5. So this is a partial fractions for this left hand side. Okay, let's take 1 divided by 5 outside. We have 1 divided by z plus 2 minus z minus 2 divided by 1 plus z square. Keeping this in bracket. So this is equal to 1 divided by 5. Okay. Now because we need the expansion to be in the powers of z, right? For that we need 1 minus z or 1 plus z. And for the expansion we need 1 plus something or 1 minus something. So to get this 1, let's take 2 common from the denominator. So taking 2 common from the denominator so that we can get 1 plus something, and something that is z divided by 2. Right? And writing the second term to be z minus 2 divided by 1 plus z square. Taking the denominator to the numerator. So it is 1 divided by 2 into 1 plus z divided by 2 to the power negative 1 minus z minus 2 into 1 plus z square to the power minus 1. We are already having 1 plus something, so there is no need to make any change. Let's multiply this 1 by 5 inside now. So this is 1 divided by 10. If you expand this, you will be getting, if suppose z by 2 is your, let's say, t, so you have the expansion 1 plus t to the power negative 1. You need to expand this, right? So this can be expanded as for mod t less than 1. It is 1 minus t plus t square minus t cube up to infinity. And in the summation format, we can write this as summation minus 1 to the power n t to the power n. And n is starting from 0 to infinity. So making use of this expansion, we can write here the summation n going from 0 to infinity minus 1 to the power n. Here your t is z by 2. So z by 2 to the power n for mod of z by 2 less than 1. What is given to us? It is given to us that mod z is strictly less than 1. So from here what we can say, please note that if mod of z is strictly less than 1, then it is also strictly less than 2. From here we can say that mod z is also strictly less than 2. Yes, which means mod of z by 2 is strictly less than 1, which is the condition for this expansion, for mod z by 2 to be strictly less than 1. It simply implies that mod of z by 2 is also strictly less than 1. So we can have this expansion for mod z strictly less than 1. It is very important. Then minus z minus 2 divided by 5. We need to expand this. Now here now t is equal to z square. For this expansion, if I expand 1 plus t to the power negative 1, if I take this t to be z square, we can have again this expansion and again this summation. So just replace t with z square now for writing this summation. So it is the summation n going from 0 to infinity minus 1 to the power n into t to the power n. T is z squared. So it is z squared to the power n. That is z the power 2n. So hence we have proved this result. Okay, thank you. Stay blessed.